Hi, my name is Dr. Ain. In this video, I will share with you about Nernst equation in electrochemistry. In part 1, I will explain the basic component in the formula of the Nernst equation and continue with the factors affecting the cell potential. In part 2 is focusing the application of Nernst equation with the example calculation. This is based on the available YouTube video. So at the end of the both video, so we will be able to describe and calculate the Nernst equation, and then you know how to use the Nernst equation to determine the concentration cell and pH. Okay, basically the most redout reactions are not performed under standard conditions. So what do you know about standard condition? So standard conditions are the governor itself perform at 298 Kelvin. I mean at 25 degrees Celsius at 1 atm and 1 molar concentration. So Nernst equation is used to determine the cell potential under non-standard conditions at any known temperature, pressure, and also concentration. So the slide show the formula for the Nernst equation. Okay, so based on the equation, the cell potential is E cell. Okay, and then E naught cell is the standard cell potential. So what is R? R is the universal gas constant. The value is 8.314 joule per Kelvin per mole. T is absolute temperature in Kelvin and its number of mole. Number of mole here is the value or mole of electron transfer between the oxidizing and reducing agent. So F is the Faraday constant. The value is 96500 C per mole. And Q, ln Q here, Q is the reaction quotient. Reaction quotient, which is an expression relating to the concentration of product and the reactant raised to appropriate power as defined by the stoichiometry of the balance overall equation. That is for Q, reaction quotient. So by substituting the value of all constant in the Nernst equation for the governor itself perform at standard, at 25 degrees Celsius, so give the following equation. The slide show two equations, one in ln Q, the other one under log Q. Okay? Okay, next we move to the factor affecting the cell potential. So based on the based on the Nernst equation, the magnitude of the cell potential depends on temperature. Okay, so at lower temperature, so the term RT over NF. Okay, please refer the Nernst equation. So at lower temperature, the term RT over NF becomes smaller. So this the magnitude of cell potential increases. Okay. The second one factor that affect the cell potential is concentrations of product. So based on concentration of products, when the concentration of product decreases, the term RT over NF ln Q becomes smaller. So thus the magnitude of cell potential increases. The third one is concentrations of reactant. So when the concentration of reactant, okay, when the concentrations of the reactant decreases, I'm sorry here is decreases, not increase. This is wrong in the slide. the concentration decreases, the terms RT over NF ln Q becomes larger. The value here become larger, so thus the magnitude of cell potential decreases. So I repeat here, when the concentrations of reactant decreases, not increase here, is decreases. So the term RT over NF ln Q become larger, so the magnitude of cell potential is decreases. Okay, the last one is the type of half cell used. Okay. Here, in cathode, if the half cell with more positive reduction potential is used, the standard cell potential in not cell increases, so thus the magnitude of cell potential increases. Okay, okay. So E cell increase when we use more positive reduction potential. So in anode, if the half cell with more positive potential in a cell decreases, thus the magnitude of cell potential decreases. Okay? Okay, thank you for watching this video. So I hope you now know how to use the Nernst equation, and then you understand about factor affecting the cell potential. So I hope you all don't forget to do an exercises related to this topic. And bye. See you next video. Assalamualaikum.